Alright, today's assignment is basically writing functions that describe the sequences that you find in story problems from context. And so here we'll just take it one at a time. We'll start with number one. Here at this bank, you're investing $1,000 into a savings account and it has a 3% annual interest for 10 years. Okay, so we're going to write a function that describes the acquirement of money. We need to have the critical information, which is our starting value, which is $1,000, and then this 3% annual interest. If you're going to figure out what your amount you have in your bank, if you add 3%, you need to multiply by 1.03. Okay, and you can think of that as 103%. So when you're figuring out how much is going to be in the account after a year, you have to add 3%. Well, that's 103% total of what you used to have. So that's why we're going to multiply by 1.03. So we get our common ratio, because you're multiplying by each time, which is 1.03, and our starting value, you can write our functions. The recursive one is a sub n equals a sub n minus 1 times 1.03. And then the initial value is 1,000. The explicit function is going to follow the geometric one because it's geometric. And so we're going to have start value times what you're multiplying by each time to the n minus 1 power. And then we have a question here asking how much will we have at the end of 10 years? Well, you basically just figure out what term in the sequence that is, and you plug that into your function. And since we start, the first term in the sequence isn't at year 1, it's at year 0. And so 10 years will be the 11th term, because we got to shift it over just that once. And so we're going to plug in 11 into our explicit function here. So we're going to get f of 11 equals 1,000 times 1.03 to the 11 minus 1 power, that's 10. So do 1.03 to the 10 power, times it by 1,000, and once you do that, you're going to get something like 1,343. And since it's money, you really don't need all those decimal points. And so if you look at it in your calculator, and you calculate it there, you're going to get a lot of decimals, just rounded off to 2, and so you're going to get 0.91, or I guess we can round up, but the bank won't. But typically we just round up if it's more than 5 after that. Okay, so there we go, $1,000, about $1,300. Okay, number 2, Grub is eating food. The sequence goes 22, 18, 14. As a reminder, if you're trying to, succeed in word problems, you should read it first. So make sure you read it, and then the next step is to understand what you read. And I did that here. I just kind of wrote out what the sequence looks like, and as I look at that sequence, I notice I have a common difference. It's subtracting 4 every time. So my d in my functions, my common difference, is going to be negative 4. And my initial value is 22. So I'm going to write that here. D equals negative 4. Okay, so now that we got that, we can write our functions. The recursive one always just kind of that same form. It's arithmetic, so follow the arithmetic form. A sub 1 is 1,000. The explicit function is going to be f of n equals negative 4 in front of n minus 1. And then add 22 on the end. And now we're going to answer this question here. How many days will it take before Grub eats no lunches at all? Well, if you just keep subtracting 4, you'll get 10, 6, 2, and then negative 2. But that's where he'll have 0 there. So that's 1, 2, 3, 4, 5, 6, 7. That's on the 7th day. If you don't want to keep writing out the sequence, and sometimes it would be really far down in your sequence, you can just plug in your number here, no lunches at all, that's 0. And then you plug it into your, you plug that into the left side of our explicit function here, and you solve from there. So we would have our equation looks like this, and then you solve for n. So you'd subtract 22 on both sides, and divide by -4, and go on from there, and that will get you a 7. You'll want to round up, because you want to make sure he only has 0 lunches and not sorry, you don't want to have it so it's more than 0 lunches. You want less, so you'd round up.